Hello, everyone, and welcome to part 2 of Educational Neuroscience Applied to Classroom Instruction and Intervention, the Teaching Brain Literacy Movement. My name is Sandra Husel, and I have been very proud to be the admissions director at Eaton Arrowsmith for probably the past 18 years since we began here in Vancouver, BC. And my role today is simply to introduce Mr. Howard Eaton, the founder and director of Eaton Arrowsmith. So Howard, I'll let you take it away from there.
Thanks, Sandra, and thanks for coming back and joining us. I know we have some new people joining us today, which is very exciting. And I know Dr. James Hale and myself look forward to doing more webinars in 2022. I think we're up for it. We got a lot to talk about. We're kindred spirits in our interest in making a difference for those with learning disabilities, attention disorders, whatever label comes out, brain injury. So we have a lot on our mind and a lot to talk about. So today I look forward to more discussion on intervention, where we're headed in intervention, what it means for classroom teachers, what it means for neuropsychologists, psychologists who are involved in assessment. Where that might lead one day is also an interesting topic. So with that, unmute yourself, my friend Brad, and I look forward to the presentation with you. I know Brad's going to be going through section 1 with you, and sometimes I interrupt him and ask him a few questions, but I'll try to do a bit less today, Brad. And then in section 2, I'm going to join a bit and talk about some of the research we're doing with brain injury and learning disabilities as related to white matter connectivity, which I think with universities in the United States and Canada. And I think Brad is interested in what we're doing there. So thanks Brad for giving me that time. So with that, Brad, it's all yours.
Well, thanks, Howard. You know, one of the things that I'm trying to accomplish with the brain literacy movement is, you know, how do we get this applied in the real world? I've presented all over the world and usually get, you know, wonderful evaluations and so forth. But as I said last time, what does it mean to change your practice? And obviously in a 4-hour webinar, it's not going to do that. But what I'm going to do is hopefully plant some seeds for you today about how this can really impact your practice. And we're going to deal with a lot of science. I'm a scientist as well as a practitioner. I was trained in the old APA style. Scientist practitioners are the way to go. So let's get on with our part 2, where we're going to talk about intervention and what it means for you. Next slide. So using assessment data to inform instruction and intervention. Okay, next slide. I want to just kind of reiterate some of the points I made last time. One of the things that we need to help educators and other practitioners understand is there's a lot of myths and stereotypes out there that we need to break down. That, you know, diversity is an important thing to consider in so many different ways: cultural, linguistic, racial, ethnic, you know, gender and linguistic, and, you know, I mean, there's a lot of diversities out there, but we need to start paying attention to cognitive diversity because it's a very cognitive diverse world out there. I've actually done some research that shows that there's significant profile differences in the typical population. About 80% of people in the real world who aren't labeled with disabilities have significant strengths and weaknesses. So brain literacy is not only about understanding disability, it's about understanding diversity in the classroom so that you can meet individuals' needs so they don't need to be labeled with a disability and they can be served in general education as whenever possible. So we want to look at the intersection of curriculum, instruction, and student response. Data is everywhere. You know, a lot of people think, oh, to think from a neurological or a neuropsychological perspective, you have to have a neuropsychologist who does neuropsychological tests. Yes, we help with that kind of thing. I'm a neuropsychologist and I really understand kids well when I conceptualize a case. But the reality is there is data everywhere in those classrooms in your observations. And if you can think from a brain literate perspective, you are going to impact children's lives much more, because it impacts academic instruction and classroom management. One of the biggest causes of teacher burnout is students that are out of control and not learning and struggling. And, so a brain literate perspective is able to take and understand those things and meet students kind of in the middle so that they achieve and feel more successful. What's the best reinforcer in the classroom? The best reinforcer in the classroom is classroom success. So if a student is experiencing success because of your instruction, they are going to be much more happy. And you're going to be much more happy and less stressed out. Because as you know, if you're a practitioner, students act out when they're unhappy or unsuccessful. So we want to develop students' brains for adaptive functioning in the real world in real time. And we've got to bridge this science practice divide. There's so much science out there, guys. I'm going to present a lot of it to you tonight about intervention and the brain. And the problem is we're just not exposed to it. Next slide. And so next bubble. We published this journal article translating neuroscience theory into practice. And this whole idea of knowledge translation, if you're in medicine, you've heard of it before. It's less common, you hear about it in education. But really, the goal of the brain literacy movement is to make sure that this research gets into the hands of the people who can use it. It's not about another publication. I got over 50 of them, who cares? It's about how do we get this into the hands of the practitioners so they can have a better experience in helping children, whether you're a psychologist or a social worker or an educator, a teacher, or even a parent. How do we get this knowledge about how the brain works so that they can serve kids better? Next slide. So we presented this last time, but if you think about it for a minute, it's really odd because teaching changes children's brains, but almost no teachers are exposed to this in their education curriculum. On the other hand, you've got all these educational neuroscientists who know about brain function, and I'll share some of that with you tonight, but they don't know about education. So they have no idea how to apply this in the real world or what this means for educators in the real world. And so that's what my brain literacy movement is all about. And that's why I'm so excited to be here with Howard and his team tonight, because they think very similarly to I in terms of what needs to happen about getting practitioners literate in understanding how their practices actually change children's brains. Next slide, please. Well, one of the problems is who's best able in the schools to help bring neuroscience to education? It would be school psychologists, don't you think? Because they're taught all about the brain, don't you think? Well, one of the problems we have, though, is one of pragmatics. We don't have enough school psychologists out there, so they have high caseloads, multiple roles, and you end up doing so much that none of it really gets done thoroughly. I find over and over, and this isn't only school psychology, it's all of practical psychology. We don't get trained very well in case conceptualization anymore. I think I told this story last time, but I was in a meeting just a month ago where a parent said in the middle of my presentation, "Stop," with big eyes, putting her hands up. She said, "I've been in these meetings for over a dozen years and nobody understood my child like you have in such a short amount of time." Case conceptualization is key, and brain functioning is what helps me understand case conceptualization. Well, but also understanding of the environment, the developmental history, the family social background, the academic background, and so forth. I mean, it's all part of the bigger picture. And one of the things I teach in my practical courses is how do we integrate all these different pieces to understand the whole child. And but unfortunately, school psychology has gone to more a behavioral route in recent years in terms of training. So not a lot of training in individual differences or classroom instruction or the neuroscience of learning. One of the problems we have in the schools is they say, well, you know, they got a social problem, they're on the spectrum. They got a learning problem, they're LD. They got an attention problem, they're ADHD. Why do we need tests? Just give them all the same thing, right? But it's not tied to instruction. Over and over again, those psychological reports, yeah, we qualify a kid or not, but we often focus on describing the tests instead of the child. And we seldom search for ecological validity. So maybe we get a low score in a particular area, working memory, auditory working memory, let's say. You know, where does that show up in the classroom? Well, the kid asks for a repetition of instructions. The kid follows the instructions wrong. The kid asks for repetition in oral conversation. The kid says, huh, you know, doesn't hear correctly. Anyway, so evaluations are often used to determining qualification in the schools, what we call test in place practice, where all it is about, and so many people see the psychologists in the schools as only doing this. Do they qualify or not? And that's actually a team decision, not an individual psychological decision anyway. But, you know, I remember when I was first in training, I was an intern. And I remember I started to go into describing all the child, and everybody around the table was looking at me like, wow, whoa, that's him. Yeah. And the director of special education was tapping the desk with her finger going, and the IQ is, you know, in other words, your job is just to give us the IQ, Dr. Hale. We don't care about anything else. Or I wasn't a doctor at the time, but anyway, next slide. So when we think of assessment, another thing we need to kind of think about is the tension between what we call nomothetic assessment and idiographic assessment. Nomothetic assessment is what we often are tied to in the schools. What's the normative score? You know, how does this individual compare to the norm? And that final product. And you look at levels. But when you look at levels of performance in those normative scores, what often we're tricked into thinking is low scores are because of low intelligence and high scores are because of high intelligence. And that is just such a superficial way of looking at children. It's easy to dismiss what we do in the schools or in clinics as just an indication of how smart they are. That's what happened with the spectrum. We were just talking about autism spectrum where earlier tonight, where everybody thinks the only difference is whether you're, you know, how intelligent you are. There are no subtypes. Well, subtypes are coming back, guys. And the next DSM might revert to earlier things. And there's brain-based differences between kids with autism and Asperger's. So just to keep that in mind as we move forward. But idiographic assessment, on the other hand, you compare the individual to themselves, those intra-individual differences. And you focus on that assessment process. One of the things I always tell my students, and I encourage teachers to do this as well in the classroom, is to take a lot of notes about kids. What are they saying? Are they blinking? Do they cough? You know, what are they saying? What words did they struggle with? What was the wrong word they had? And I know that's hard to do as you're instructing in a class of 30 kids, but if you can just jot down some notes about kids, things that kind of stand out to you, you'll be a much better teacher. Same thing as in your psychological evaluations. Write down those notes, whether you think they're relevant or not. You just write them down and try to understand it all, including the nomothetic part, but also the idiographic part, because that's what's going to make you a better practitioner, is looking at those patterns of performance and how those patterns of performance vary. One of the things that we often make the mistake of thinking is that, you know, when we take that snapshot of that kid in our evaluation, that we know that kid. But kids vary. And what we often miss in our assessment practices is that kids vary over time. And this is what the whole CBM approach and ongoing progress monitoring really helps us understand as practitioners, is that kids will vary from time to time for various reasons. Maybe they didn't have breakfast this morning. Maybe they got in an argument with their parent. Maybe there was a fight on the bus. You know, I mean, there's lots of reasons why kids vary from day to day, including executive function. One of the things I'm going to talk a little bit about ADHD later, but you know, what's the most consistent thing about children with ADHD? Inconsistency. Inconsistency. So if you just get them on one day at one time, you're going to get a much different picture than if you measure that person over time. And I'm not saying we need to do repeated psychological evaluations over and over again with kids, you know, on a regular basis. But what we need to get better at is helping the teachers in the classroom monitor performance and modify instruction accordingly. And that's what expert teachers are all about. And that's what brain literacy hopes to achieve. Because both idiographic and nomothetic assessment are important for helping kids learn and behave better. Next slide. So, you know, one of the things that I wanted to put up here and talk about just briefly is, you know, we can't do the kinds of evaluation that I argue for, which are more comprehensive evaluations, if we don't prevent kids from being referred. One of the problems with our system is that it's all about everybody's normal, but you know, the abnormal kids we throw to special ed. And we've been trying to change that for, I don't know, Howard, what do you think, 40, 50 years? You know, like forever, for people to get that out of that mentality that everybody's a blank slate except for these weirdo kids that need to go in special ed. And that's just wrong. There's kids in general ed who need different help, and there's kids in special ed that need different help, but they may need the same thing. So we need to think about this through a multi-tiered approach. And the approach that I advocate includes the standard protocol RTI approach at tier 1, the problem-solving approach at tier 2. But if they don't respond, then we need to do a thorough evaluation before we look at individualized special education. And individualized special education does not mean it can't be in a fully inclusive environment. Special education doesn't need to be pull-out all the time or in segregated or self-contained classrooms. We need to think about how we can help those gen ed teachers provide that kind of individualized instruction, which is difficult in large classrooms. But if they're empowered by understanding how that kid learns, because the psychologist did a good job evaluating him and said, this is how this kid learns, then it's not so uncomfortable. As I talked about last time, teachers in general are perfectly cool having diverse kids with diverse needs in their classrooms. But they repeatedly say in survey research, we're not trained to do this. So that's part of their educational training. We're not very good at training teachers to understand cognitive processes and how that goes into their academics. Anyway, when I did this multi-tiered research, where we did RTI and we did it well, and we progress monitored and we provided interventions and so forth, we were able to, if you can look at the second part of this slide, in a year, we're able to go from almost no one advanced in reading to a lot of kids advanced and proficient, not very many kids still below. Now, you're still going to have kids below, but the reality is, at the third part of this slide here, in the 4 years that we did this research in the RTI, you know, in the multi-tiered school, and we were doing comprehensive evaluations for kids who were non-responders, wasn't straight RTI. But the fourth year we did this in the RTI school, every single, we not only reduced our referrals for evaluation by 20%, which is a lot of work, right? If you're doing 20% less evaluations, you can be much more thorough, can't you? We not only reduced our referral rate 20%, but every single kid who was was evaluated did indeed have a disability. So what I'm arguing with this slide is we really need to think about how we can prevent and provide early intervention for kids who are struggling so they don't need comprehensive evaluations and disability services.
Hey, Brad, if I could ask you, with response to intervention, were you doing like a phonological awareness, phonics training, or like was there a specific curriculum you were following for reading and math or what?
No. So tier 1, it was basically the standard protocol approach where evidence-based instruction, I mean, phonics was provided, of course, for reading. It was using the evidence-based approaches and then high quality teaching with regular progress monitoring. So we didn't individualize at all. The problem-solving approach is what's advocated by the National Association of School Psychologists, is trying to figure out why the kid's not learning. That's tier 2. And then providing a much more individualized or targeted intervention. And we figured out if they don't respond at tier 1 or tier 2, they needed the kinds of comprehensive evaluation I argue for so that tier 3 could serve their individual needs. And a lot of those kids were still in the gen ed classroom in tier 3, even though we identified them with a disability.
So it's sort of a way to slow down the fast referral to special ed services in a way, right?
Well,
because you're asking for the problem solving section there where you want to gather and discuss ideas and strategies type concept.
Yeah, my goal would always be to prevent that child from needing the comprehensive evaluation in special education. We have to be a little careful with framing it like we're slowing things down, because at least here in the United States, the government has come out and said you cannot use an RTI process to slow down the need for a special education evaluation.
Right.
So I think you and I are on the same page here, but I just wanted to reframe that so that people don't think that slowing down an evaluation is a good idea.
Right.
Okay, next slide. And then bubble. This is a 58 author white paper I did. And so that's 58 authors, top leaders in the United States, and it was to argue for United States law. So it did not include people outside of the country of the United States, but we have physicians here, psychologists, neuropsychologists, educators. We've got people, leaders across the nation, people in psychometrics, people in evaluation and intervention programs and so forth. And here's what we concluded in our 58 author white paper. Notice, toot my own horn up here, Jay Hale's the #1 author. Can you imagine? It was like herding cats for sure.
Well, you got Nancy Mather in there, the Woodcock Johnson.
Oh yeah. There's a lot of big names on there.
Sally Shaywitz, those are big names.
Yeah, Cecil Reynolds. Martha Denkla, probably the top physician. She's a neuropsychologist and the wannabe Martha Denkla. She and I published a paper on ADHD together. Anyway, what we concluded was an empirically validated RTI model could be used to prevent learning problems, but comprehensive evaluation should occur for SLD identification purposes, and children with SLD need individualized interventions based on learning needs, not merely more intense instruction. And if you read the RTI proponents, they're still arguing, if the kid doesn't get it, just provide more intense instruction. Don't modify your instruction. Don't try to figure out why he's not responding. Just give him more. It's almost like they really want us to dumb things down. So in other words, if a hammer didn't work, pull out the sledgehammer. Try again. And think of what that must do to kids. You keep giving me phonics and I understand phonics, but my working memory is terrible, so I don't comprehend what I read. But come on, more phonics and more intense phonics over and over again. And what that must do to kids' self-esteem, because they go like, geez, what's wrong with me? The teachers are telling me this is what I need to get better at reading, but I'm not succeeding. It was actually what happened to me when I was a special ed teacher that made me become a neuropsychologist. Was I did the same thing with another kid, and I felt very sad for that kid when I realized it was I who had failed that kid, not the kid who was failing. Next slide. So I knew we had too much content to cover tonight, so I'm going to fly through stuff, as you can imagine. And but I'm just going to hit some key points along the way. You will get a copy. Is that right, Sandra?
Yeah.
Of these slides. So some of them you'll just have to refer back to on your own. My attitude in presenting is always give too much, and they can always go back and read and email me questions and so forth. So brain literacy, instruction, and intervention. Early intervention, guys, early intervention is pretty key. You know, we need to get to these kids early. One of the problems I had when I was living in Canada was some school districts would say, we won't evaluate a kid till they're in 3rd grade because they won't meet discrepancy criteria. And that is the exact opposite of what we should be doing. We should be identifying these kids early, even if we're just doing it through CBM and problem solving and multi-tiered approaches, so that we don't need to do comprehensive evaluations. Because if you wait till 4th and 5th grade, they've had 5 years of failing. No, we need to find better ways, for lack of a better term, I'll use a medical term, triage our resources to figure out how we can help kids the earlier, the better. So we need to use this MTS framework, and we need to recognize that cognitive diversity doesn't require fancy tests or segregated one-on-one instruction. You may need that for non-responders or kids who have serious disabilities. I'm not saying we can erase all disabilities, but there's data everywhere. I love to show a case of a kid who was diagnosed with ADHD, who has a terrible writing sample, but because of the things you can see, like self-corrections, which kids with ADHD don't do and so forth, just from his writing sample, you can understand how to instruct him. So student class performance and behavior, especially error analysis, can provide instructional clues for brain literate practitioners. What's the one piece of advice I can give you for intervention? Don't let a kid say, I don't know. Make them respond. Because those responses, when they're error responses, will tell you what's going wrong. A brain literate teacher will understand an error and an error pattern. And once you start to identify different error patterns, you can see the kinds of problems that are going on and then accommodate that student and provide the direct instruction they need to be successful. Error analysis is key. And I just don't let kids say, I don't know when I'm testing them. I mean, you know, I just say, give me what you got. Just give me something so we can move on. And they learn pretty quickly. They got to say something, or they got to do something, or they got to point at some picture. And that tells me how to teach them, what to do to help them in intervention. But providing this whole idea of providing the same intervention for every kid undermines inclusion, and it ignores cognitive diversity. Cognitive diversity is the norm, not the exception. So we need to stop thinking about everybody's a tabula rasa, blank slate, normal, and then we have the abnormal special ed kids over here. We got to find out who they are and get rid of them. That just needs to go away. If you don't think that you have strengths and weaknesses, you got one. It's called denial. So, you know, the reality is we all have strengths and weaknesses, and anybody who knows me well knows I got plenty of both. So, but that's something we should engender and value in our diverse society, shouldn't we? It shouldn't be just the color of your skin or your ethnicity or your language. It should be also how you think and how you learn. And let's show respect for people with learning differences instead of saying, you're bad, you're wrong, you're disabled, you're a loser, is essentially what kids learn. I think I mentioned this last time, but one of the sad things that I've been asking kids now for about 20 years, I say, you know, when they're coming in for an evaluation with me and they've had other evaluations or they've been in special ed, and I say, how come learning's hard for you? And a majority, about 90 to 95% of kids conclude I'm dumb. And that's a terrible message that the education system gives to kids who have special needs. You know, we need to help. And I think Howard mentioned this last time, one of the things we didn't need to do is not only educate educators about individual differences in learning, but educate the kids. I mean, wouldn't it be great if we had a regular, you know, we have social skills classes and all these other things in the school. How about we have a class where we talk about differences in learning and thinking and behavior? Maybe we'd have more tolerance and respect for our differences in our classrooms. Okay, where was I? So that brain literacy can help you consider alternate interventions or how you modify your instruction to meet individual needs. And one of my goals is to it's not like a program. You're not going to get Brad Hale's program. It's more about how do I modify my questioning? How do I modify my requirements? How do I find the good things in the responses that my student made, which may not be exactly right, to build up their own confidence? Like I said before, the number one reinforcer in the classroom is success. It's the most important thing. And if every child feels success in your classroom, they will all achieve better as a result. So learning and behaviors problems, and this is another thing, I've written a paper on this, I'll talk about in a minute. We need to remediate deficits. We need to stop accommodating learner deficits or building on strengths. When you think about brain development, and we're going to talk all about brain changes with intervention, it's about changing pathways instead of reinforcing dysfunctional ones, because the brain will adapt to whatever you give it. So if you tell a kid, we're only going to focus on your strengths and we're going to ignore those weaknesses, you are making their brain even more dysfunctional. And I know that's hard to hear because a lot of the things we're told to do, we're told 504 is accommodations. Just provide accommodations. Give them less materials in class. Make them do less assignments. Provide another way to respond. Those accommodations are undermining brain development. And brain plasticity is greatest in our children. It is throughout life, but it is greatest in our children. So darn it, we need to get them to overcome their disabilities as best we can, or at least mitigate them, instead of using some of the strategies we're told to do in the classroom. And I'll come back to that later. Next slide. And I wanted to bring this up because a lot of people think when they hear a neuro guy presenting on education that I'm going to say, well, you know, do the Hale Lockey method, and you know, we're going to do this, and you know, no. Brain literacy is about taking the best evidence-based practices in education that science tells us to use, understanding how the child is going to intersect with those empirically based programs, and then tweaking the interventions using a problem-solving approach so that they meet the child's needs. And I want to just highlight for you some of the things that we do in classrooms, which are, you'd be surprised. Effect sizes basically say how powerful the intervention is. And John Haney's synthesis of 800 meta-analyses really tells you what's the good thing to do in a classroom. What's the good thing to do in the classroom? The best thing to do is give kids regular feedback, provide direct instruction, remediate the weaknesses. Okay, what's some of the worst things to do? Retain a kid, hold them back. Team teaching, believe it or not, is pretty low. And that's probably because the teachers neither of them understands the brain aspect of it, and so they struggle with it. You know, individualization. The problem with individualization is people who are doing the individualized instructions don't understand how the brain works. And so they're shooting in the dark. It's a trial and error approach. Anyway, computer instruction, which we love to plop kids down in front of computers, not very strong effect size there, guys. A lot of the stuff that we do well in classrooms, like goal-directed learning, peer tutoring is a fairly powerful one. Homework. I mentioned this last time, but homework is pretty important. You got to do homework. You got to practice. Think about the brain for a minute. The brain gets good at things by practice. And homework is a great way to practice. Why we decided to get rid of homework is beyond me. Oh, it doesn't make a difference, some study said, and boy, that sounds easier to me. If I'm a teacher, I don't have to give any homework. I don't have to grade any homework. But kids practice doing homework. And if they're not doing the homework right, you hook up with the parent to figure out how they can be successful in their homework. Practice makes perfect. I mentioned that last time, but the brain doesn't get good at things unless it practices them over and over again to automaticity. And that's why our kids with disabilities are so tired all the time. It's because they don't practice anything to automaticity. And so they're using too much of their brain. And so I can't do anymore. I can't do anymore. The only way to get them to overcome that is practice. And I think Howard mentioned this last time, didn't you, Howard? That we need to help kids understand why that repetitive, boring practice of repetitive learning is important.
I think they get it for the judo class they like, or the hockey move they've developed an expertise for, or the piano piece that finally they learned by mastery. But we need to apply it in the classroom concept to make kids understand that.
Yeah. And we've been moving away from practice for, at least the last 10 years, and we're seeing it in educational outcomes.
Mm-hmm. And I'll be showing slides that show, the more efficient you become at something, the less, energy neurologically you use it becomes automatic, and you don't have to apply it it doesn't slow down the processing of other information.
Yeah, I think I mentioned this last time, but 7 times 7 is 49.
Mm-hmm.
I learned my math facts. I didn't do any math there. 9 times 6 is 54. I didn't do any math. But what it does is it frees up my working memory so I can do harder math. Mm-hmm. Anyway, when I see teenagers still counting on their fingers as they're trying to do a math problem, no wonder they can't do algebra. Mm-hmm. Anyway, next slide. Next slide. Okay, so now we're going to talk about brain changes with intervention. And I'm going to present some slides on reading, math, and ADHD. But we're going to start with Howard's work, which, when I first met Howard, I don't know, 10 years ago or whenever it was, I said, you guys need to do some research. And they took it and they made it happen. And it's slow and it's costly and everything else. But, oh my God, like a good scientist, without science to back up what I'm saying, I got a problem with it. And I told them that, and they said, and they believed it, and now they got science. So let's hear about it.
Yeah, well, thank you, Brad, and I look forward to reviewing some of this information. Sarah's going to be putting up a PowerPoint here shortly that I'll be discussing. I have been involved in the field of learning disabilities all my life because I was diagnosed with severe developmental dyslexia in grade 1. I never thought I'd get into education. My parents thought, they had actually thought of purchasing a farm for me outside Vancouver, so I'd have an occupation. I was so severely dyslexic. But I ended up doing a psych degree at UBC and then special education degree at Boston University, and coming back, doing some PhD work before I but met Barbara Arrowsmith Young. At the time, I was doing psych ed assessments with a group of psychologists in Vancouver, had conducted over, 2,000 psych ed assessments. So I was very familiar with the assessment world. I was familiar with accommodations, technology and strategies, bypassing learning weaknesses. And then Barbara Arrowsmith Young came to my attention through parents. And, sometimes in life you have aha moments where someone brings you a concept, an idea that just totally changes your way of thinking. And she did. She brought to me the idea of neuroplasticity. She was one of the first educational neuroplasticians in the world, having come up with ideas to improve cognitive capacity over 40 years ago. in Toronto. And you can imagine in education, where the paradigm was the brain was fixed, you have a learning disability the rest of your life, and accommodations and strategies are the norm, that her work was not well accepted in that paradigm. I thought it would be. I was naively positive when I came across her work, and then I realized even my own peers were not fans of my interest in this remarkable work that she had started in 1978. But I decided that this is something I wanted to bring to Vancouver. And one of the things I was interested in was doing research, not myself per se, but bringing in really excellent neuroscientists, researchers at various universities to study her program and to do fMRIs, to do EEGs, to do behavioral assessments, cognition, and for them to have free independence with their research to decide to publish or not publish. And I was involved in helping raise funds from donors around the world to help with this research, because my purpose and my passion was to make a difference for those suffering with learning challenges, and because of my own. And so it was a personal mission on my part to help change the way we look at children and adults with learning disabilities. We also brought the work into brain injury. We started seeing students at our school at the University of British Columbia who had brain injury, and they wanted to know, would the program help them? And Barbara Arrowsmith Young said, hey, why don't you give them a try? She had found success in Toronto. And from that, we started a company called ABI Wellness, where we bring her work to the brain injury community, where we have ongoing research with Brigham and Women's Hospital with Dr. Kim Wilmette, who's a neuropsychologist. She's actually using the program I'll talk to you about with her own clients. So she's a neuropsychologist, a researcher who's actually implementing the program to improve cognitive capacity with those with brain injury. And then Mount Sinai Hospital in New York is very interested in long haul COVID patients who continue to have problems with executive functioning post the acute phase. So I want to talk a bit about that research, and then I'm going to highlight some of the research we're doing with the Arrowsmith program. And a lot of it is around improving white matter connectivity, or these large scale brain networks that I'll discuss. And on the right there, you see a pretty interesting picture of white matter and what looks like brain wiring that you might find in a computer system, but that's essentially the human brain. And so the human brain's made up of these amazing connectivity networks and areas that have to communicate in a very functional way, or you could result in, if they don't, some serious cognitive complications. So next slide. So again, the focus with Barbara Arrowsmith Young's work is change cognitive capacity. So the learner's cognitive capacities can be strengthened. Again, this goes against the norm in the field of learning disabilities, not so much in the field of brain injury, because there's a lot of work being done in cog rehab, but even in brain injury, there's still a lot of compensation strategy work being done for executive functioning. But in learning disabilities, the idea of strengthening cognitive weaknesses is still not well understood. I think it's becoming well understood in the area of reading capacity, with phonological awareness and phonics training, work with Dr. Sally Shaywitz showing improved network connectivity in areas involved in reading, but it's still at a very microscopic level of awareness that concepts like working memory or fluid intelligence or processing speed can all be improved in terms of capacity. And if they can be improved, what about this label of lifelong? That should be questioned. And we'll talk a bit about that later. Next slide. So again, the idea is to target specific structural functional changes in the brain and providing novel stimulation to get to the point of effortless processing, and then create more novel stimulation to effortful processing. So we look at specific cognitive functions, the networks involved, and we want to target those individually for each child. What's interesting with the Arrowsmith program itself is that it is actually being used in classrooms. I don't know if you know this, Brad, but in like grade 1 classrooms, grade 3 classrooms. So the whole class is actually doing one of the cognitive exercises I'll be talking to you about. So everyone can benefit from a very comprehensive cognitive program and help likely eliminate the idea of learning disabilities or reduce the number of kids who grow up with significant cognitive challenges, which then lead to diagnosed learning disabilities. So the work is now being incorporated by teachers, certified teachers in regular classrooms across a grade 1 group of all types of learners. Next slide. Again, we recognize that each child has a unique cognitive profile. This is exactly what Dr. Hale was talking about. Barbara over the years has probably assessed thousands and thousands, I don't know, tens of thousands of children. Each one has very unique profiles, and their learning difficulty is usually due to some cognitive load. There's a specific functional networks or areas of the brain that are just not connected or working properly. Therefore, they become overwhelmed with processing information, and their brain, shuts down. And each child has their own profile, their own program as we go and work with them. Next slide.
Yeah, Howard, if I could just mention, one of the things that we need to kind of get through, and you're highlighting here, is, it's not that disability is just low. Disability can be high. Disability can be low. And it can be differences between networks of low and high functioning that leads to disability, not just, they're just not low. Matter of fact, autism, traditional autism, or what I call true autism, their brains are overfunctioning in many areas, but underfunctioning in others. And so that's why they get so overwhelmed. You ever wonder why a kid with autism all of a sudden flaps and shuts out, and they start doing stereotypies? It's because they are overwhelmed. Their brains are on overload, not too little.
Yeah, and we'll see that with some of this data that we got on large scale brain networks. So you're exactly right. I wanted to show the audience here one of the exercises called symbol relations. Uses the concepts in an analog clock, as you see a two-handed clock here. I remember when I was doing assessments, Brad, a parent would come in and say, "Oh, my child doesn't know how to read the analog clock in our kitchen or in the classroom." And I said, "Oh, no problem, don't worry, we have digital. Now, just put a digital clock, and bypass this problem." I had no idea, Brad, how important an observation it was that this child could not tell time, because obviously telling time is a very conceptual task. Where in this clock, for example, you have to compare, a minute hand and an hour hand, and understand the relationship in a 12-hour clock. How many sections are between an hour? What is the relationship as these hands move in spatial sequences and in relationship to each other? And what Barbara Arrowsmith Young taught me was that this is a key assessment to understand how well the child can understand conceptual information in their world, especially in real time, whether it's reading comprehension, math problem solving, understanding social situations, all require ability to see concepts in isolation and then in relationship with each other in a very efficient way. It can't be slow, or else they're going to look like they're deer in headlights. I don't know how many students you've met that you met, Brad, that sort of look at you and you don't know if they have actually heard what you said, or they're uncertain about the information or choices they had to make. Now, they could have an auditory working memory problem in addition, but they could also have conceptual difficulties. And so this exercise moves from, for example, a two-handed clock to a four-handed clock to a six-handed clock to very difficult levels of understanding. And it's also interesting when you look at stroke, one of the assessments they use is a draw a clock test because of its complex visual spatial sequencing and conceptual awareness or relationships within the hands. Next slide. So if we take this one exercise, and Barbara Arrowsmith Young has 19 for various cognitive functions. This one seems to, research is showing, get activation in the area of the brain called the parietal temporal occipital lobe, where sensory information from the different lobes come together in this association cortex to help us with understanding. And one example used by Barbara Arrowsmith Young is, how do we understand the concept of a cat? And of course, we can touch a cat, the fur on the cat, we can hear the cat meow or purr, we can hear, see that it has a difference with, and with those concepts, how does it differ from an elephant, for example? So all this sensory information comes together for us to understand what a cat is. And the sensory information has to work efficiently, it has to integrate in this association area. And what research is showing is the same parietal temporal occipital lobe area where the symbol relations or clocks exercise also activates, is also where reading comprehension takes place, math problem solving takes place, understanding grammar takes place. And I remember when I first went to Toronto to look at what she was doing in about 20 years ago, I remember looking at the analog clock symbol relations exercise and saying to Barbara, is this just for telling time? And she said, no, it will improve reading comprehension and math problem solving. And as an educator, I was just trying to understand how that's possible because I was never taught, brain science. At my undergraduate level, I had a few courses in psychology. My master's level courses in education had nothing to do with brain science. So I had a lot of learning to do about neurology, neuroscience, and what was actually happening in the human brain. But here's an example where you can take what appears to be, an analog clock is just about reading time. And in fact, if you start mastering this ability, it can have crossover into other academic areas like reading comprehension and math problem solving, for example. Next slide. So one of the things we did at UBC is we, with Barbara Arrowsmith Young and graduate students and the researcher, Dr. Lara Boyd, they actually created an analog clock in functional MRI where a child would go into the functional MRI, look up and see a clock face. And then it would say whether it would give a time, like 3:10, and the person in the MRI would have, the child would have to press left hand yes, right hand no buttons and make a decision. And so we put them in this MRI prior to them doing symbol relations to see what was going on in the human brain, and then 3 months later, and wanted to know what kind of changes took place in the human brain. And what you could see in time point 1 is there's a lot of activity for a child with a learning disability who's trying to understand, say, a two-handed clock. And by 3 months, there's far less neurological activity, meaning the brain is operating much more efficiently, using less cortical space to make decisions, and can make an understanding of the conceptual connections at a faster rate of speed. And this is what I mean by if you drill and master two-handed clocks, three-handed clocks over a period of time, the brain becomes more efficient. Now, efficiency is great, but what we're also seeing is that not only can they tell time efficiently, but the brain region involved in reading comprehension and math problem solving is also operating very efficiently, and their scores go up in those areas. And this can be without direct instruction in reading comprehension. And this blew my mind when I first came across this, because I always thought, okay, if you're going to master reading comprehension, you better do a strategic approach of how you should analyze paragraphs, how you should see relationships between the paragraphs, and find a mnemonic to help the child remember the strategy for reading comprehension. And as I saw children engaged in the Arrowsmith program work on the symbol relations program, I saw through assessment their reading comprehension scores go up. And again, this is without direct reading comprehension instruction. So you can take a concept like symbol relations or reading analog clocks and become a master at reading very complex hands, and you'll see this crossover into other areas of not just academic functioning, but also social functioning, where they can understand peer relationships better, understand science class better because they understand it in real time, because they're getting the concepts at a faster rate of speed as well. Next slide. So we not only did this with learning disabilities, but we did this work with people with TBI, chronic traumatic brain injury. And we did this research at UBC, and we did a 3-month study using Barbara's program, which is also called the BrainX. And what was interesting in the brain injury field is we first went to University of Washington, Brad, to talk with a world-renowned expert in TBI, and said, we want to do this program. It's called the Arrowsmith Program. The people with traumatic brain injury would be doing, 3 to 4 hours of this cognitive work a day over 3 months. And this well-published professor looked at us and said, they would never sit that long. Someone with a brain injury would never be able to focus that long and do the research. And so she declined us immediately just because she didn't think people with brain injury could engage that well. And what's interesting with the work, and you mentioned it, that kids need success to feel engaged and want to continue with the tasks they're doing. What is really brilliant about the Arrowsmith program is that it's built on successful steps and mastery. And for the first time, many of these kids are mastering things on their own without strategies or someone giving them the answer, which is very motivating. And it's also motivating with patients with traumatic brain injury who have never been given this opportunity to improve their executive functioning. And so when we went to UBC and a researcher there, Dr. Virgie Nazil, we asked her, what she thought. She had the same hesitancy that these people with brain injury wouldn't be able to engage in these cognitive exercises because of the nature of their brain injury. And again, they were startled that we had zero loss of clients, meaning those who started the research, finished the research. Retention in traumatic brain injury is like 50% in programs. But overall, what we found was there was significant change in functional connectivity. These large-scale brain networks that are involved in executive functioning had improved function and efficiency, and we saw that through QEEG and graph theory analysis. And we also saw changes in fluid intelligence, which is ability to think logically and solve problems. And when you look at the controls versus the TBI patients over 3 months, there was a significant improvement in the 3 months in terms of those who had TBI, which again is very exciting because in the field of brain injury, not just in learning disabilities in children, but in brain injury, the idea is the executive functions are forever, these weaknesses. We have to have strategies and compensations for them to succeed. We did a second study. We looked at the RAVLT. We saw improvements in auditory verbal memory, rate of learning, also saw, again, significant brain network reorganization, and also a significant drop in anxiety and depression. And if you look at studies on anxiety and depression, brain network dysfunction is a part often seen in these diagnoses. And these people with brain injury one of the exercises was symbol relations or the clocks exercise. Next slide. What's also exciting is that we got a higher return to work. So the global return to work rate is around 40% for traumatic brain injury. We were getting 77% return to work. This is why Brigham and Women's Hospital is so interested. This is why Mount Sinai Hospital is also interested. But think about this. This is for brain injury, and you're going to see the work we're doing in learning disabilities. If you make someone more independent with better executive functioning, they're going to love school more. They're going to want to stay in school more. They're not going to need resource room support. They're not going to need the parents to help them with homework. There's just a whole change in self-esteem, a reduction in anxiety, because all of a sudden they have the control in their brain. Next slide. With TBI, we used the TBI quality of life questionnaire, which was done in 2016, normed and validated. And again, this is with approximately 30 clients engaged in our program, big changes across the board, especially cognitive functioning that we're seeing. This is why the work we're doing is of high interest at some of the largest clinical hospitals in the world. Next slide. So in terms of learning disabilities, Barbara Arrowsmith Young has been doing this work for 40 years. So this isn't just 10 years. Her work started in an experiment on herself, which a lot of pioneers do, and then moved to studies at Mount Sinai Hospital in Toronto with a researcher there, Dr. William Clancy. I started doing research 20 years ago on my own students going through the Arrowsmith program because I was so interested in research. And then in the last 10 years, Southern Illinois University, UBC, University in Spain has come on board. Brad was at the University of Calgary. So a lot of research has taken place, which we're excited about, and we're excited about more. There's now an international committee of researchers that are looking at further studies on the Arrowsmith program, which is exciting. Next slide. Again, the idea of cognitive function, the job of a region, the brain or network of regions. Again, we want to look at executive functions, visual memory, auditory memory, all sorts of areas we want to, and it's at a continuum of function from very severe dysfunction to superior function. And I've seen, I don't know, 1,500 assessments, and not any two are the same. And progress is different for everybody. Even with the TBI population, progress is varied based on their level of plasticity or brain plasticity. Each brain seems to have a different level of brain plasticity. And that's the same with learning disabilities. We see some kids who make very fast progress, improving cognitive functions, and those who are making much less in terms of speed of progress. Of course, there's an average progress level, but there's a range. And what's interesting with the Arrowsmith program, we know within the first month, 2 months, what kind of progress this child's going to be making over a period of time. We're still trying to understand why some brains are more plastic than others. With TBI, we found that the higher your education prior to your brain injury, the faster the recovery of executive function. And we think that's because there's more white matter in these large-scale brain networks for recovery. In terms of learning disabilities, again, we don't know if there's a genetic factor, physical exercise, nutrition, sleep. There's a lot to learn as to why children and adults with learning disabilities or attention disorders have different rates of improvement of cognitive function. Next slide.
I think one of the things I'd like to comment on, Howard, is what I think you're arguing for here is that you're recognizing not only the individual causes of response to intervention, but also how that interacts with the environment. Mm-hmm. And I think that's the key. You know, we come to these brain things and we see all these brains and talk all brains, but the reality is that environment plays a large role and different factors need to be considered because we want to meet the whole child's needs, not mm-hmm. just addressing our particular research interests.
Yeah, absolutely. And this is why with traumatic brain injury, we brought in meditation and aerobic exercise as part of our treatment protocol, because we know those all help with plasticity, with brain-derived neurotrophic factor, which is sort of the growth hormone in the brain. If you do physical exercise before a novel learning environment, you seem to have a better retention of information. Mindfulness can help lower, the anxiety and distress, which can help with acquiring information and improve brain plasticity. So, and we also do that at our schools. So we combine the best of approaches for brain health, for example, Brad.
Yeah, and let me just add, there's neuroscientific evidence for both of those practices.
Yes, absolutely. And that's why we brought them in. When we look at Southern Illinois University and the University of BC, those researchers, Dr. Greg Rose, Dr. Lara Boyd, they were very interested in these 4 large scale brain networks that they were highlighting: the default mode network, dorsal attention, the salience, frontal parietal, executive control networks. And Dr. Greg Rose put the ones below. So default is I'm thinking, dorsal attention, what's going on here? Saliency is what's important, and frontal parietal is how should I respond? And so when you looking at the symbol relations or clocks task, all these networks and regions in this this remarkable maze of network connectivity, you can imagine it firing left and right all over the place as it makes sense. And if you saw that first slide of an fMRI of a child trying to learn clocks for the first time, all these networks are trying to figure it out. And what we found in research, the ones that seem to be changing the most, becoming more efficient, are the default mode, which is I'm thinking. So that ability to say, okay, I'm engaged with the saliency, which is what's important for me to know here. And think about that for a second, Brad. If you look at classroom instruction that's dumbed down or simplified or more individualized, where the teacher is more with the child doing the work, you do less, the child's doing less default mode and less saliency because everything's being scaffolded. And I think that's the danger of some of the work we're doing in special ed, where we're compensating, providing information which doesn't allow them to develop these neural networks, is one of the hypotheses that I'm thinking. Next slide.
Oh, I just want to add, I've been thinking that way for a long time. It doesn't do any good for us to provide all these modifications and accommodations and make these students really dependent on the teacher. Because when they graduate from high school and they get out in the workforce, you can't say to your boss, when are you going to scaffold this for me?
Yeah, and that's why you see I worked with Dr. Loring Brinkerhoff at Boston University during my graduate days there. He was one of the first to develop a very comprehensive, post-secondary program for learning disabilities. And, we get kids who come from very structured, supported high schools to Boston University where they fell apart. And the more I've learned from the work here, from the researchers who've been investigating the Arrowsmith program for LD and for traumatic brain injury, the more I've realized that we're putting students in danger by not building these networks and this connectivity. And again, what I'm seeing with this work, you can do it for the whole class of grade 1 students, and everyone benefits. I remember when I was a teacher at Truro Public Schools in Massachusetts, I was supporting a grade 1 and grade 4 class. I was trained in Orton Gillingham, and I taught the whole class Orton Gillingham. The structure of the English language, the history of the, and every child was fascinated. Every child benefited. So if I had a grade 4 student that was reading at a grade 5 level, I would, through structured phonics, learning about syllables, they were able to decode words at a grade 10 level, not comprehend, but they got power in their understanding of the English language. So I think we could do this not just for, building structural connectivity in children, but also in teaching concepts like, phonemic awareness or phonics, using programs like Orton Gillingham or Linda Muth Bell. Every child can benefit from these things. So when you look at students without learning disabilities, their within network and between network connections are normalized, meaning there's no hyperconnectivity or hypoconnectivity. And next slide. But when you look at students with learning disabilities, there's significant hyperconnectivity and then hypo, meaning it's just not working in synchronicity that builds efficiency. And this research, if you want to, you can go to the Arrowsmith Program website and download the journal publications, look at the research in peer-reviewed journals. Some were presented in papers overseas at national conferences. Now, the Arrowsmith Program isn't the only, research, only program being studied. Researchers around the world are looking at these large-scale connectivity issues. For example, looking at the default mode network in dyslexia and finding significant problems. Looking at the default mode network in dyscalculia and finding significant problems. Looking at it for attention deficit disorder and finding significant problems. I think there's, Brad, a lot of kids diagnosed with ADHD that definitely don't need medication. But if we can build their structural connectivity, those issues would be resolved versus a medication approach. So does the Arrowsmith program change this connectivity? These individual third-party researchers at SIU and UBC found, in fact, they did. Next slide. So over either a 10-month full Arrowsmith program or just a 6 weeks of symbol relations over the summer, we were able to get these researchers were able to find the structural connectivity changed. For example, strengthening the underconnectivity seen before training, or reducing the hyperconnectivity between brain regions seen before training. And again, the two areas, the two large-scale brain networks that seem to be normalized were the default mode network, which is I am thinking, and the saliency network is what is going on. And I think that really bodes to, again, our instruction and what we're doing currently is that I think kids with learning disabilities are struggling with that initial attention, I'm thinking, and struggling with what's important to know here. And by giving them compensations and strategies or telling them, we're not building these connections. Next slide. This is some of the research Brad looked at our stuff in 2004 when he's at the University of Calgary, took some data from the Arrowsmith program and looked at it. And essentially this data is saying that what Dr. James Hale found in 2014, we're finding again in 2019 and 2018, is that we're able to improve concepts like cognitive efficiency, processing speed, fluid intelligence, oral vocabulary, all these kinds of cognitive concepts. And again, I was, before Arrowsmith, I was in the world where these cognitive weaknesses were forever. And when I first heard about the Arrowsmith program, I was interested, but boy, was I wondering, is this possible? And, over the last 20 years of working with researchers around North America, it's just really exciting to see what I saw over the past 20 years with students. Next slide. And again, more in the academic areas, as you improve cognitive capacity, guess what? You get improvements in areas of achievement over time, especially things like reading fluency and math fluency and writing fluency. These areas of ability to keep up in class, get work done in an efficient amount of time is such a problem for children and adults with learning disabilities that we're seeing that you can actually speed up written output, you can speed up reading, you can speed up math calculations with this type of work. And again, it is repetitive, it's mastering harder and harder levels. It's very, it's one of the things that parents come in who are interested and say, oh, this looks way too hard, because they're so used to finding ways to make things easier for their children rather than to challenge them on tasks that are going to be challenging for them, but they'll be successful at it. So the Arrowsmith program sort of challenges our idea of dumbing down or making easy or compensating. And it's a real paradigm shift. Although it's been 40 years, educators are in education, it's still a long way to go. I'm finding it a bit easier in the healthcare sector to introduce the concept of neuroplasticity and working on cognitive functioning than I've seen in education. Next slide. And parents are also noticing the changes. This is over a 6 week, of course, they understand reading the clock better, but they're seeing other areas of improvement through the parents observing. So not just the researchers are seeing this in behavioral data and cognitive tests or in MRIs or EEGs, but parents are also noticing these changes in their children. Next slide. And as you improve cognitive functioning, guess what happens? We've seen this not only in learning disabilities, but also in brain injury. Once those large-scale brain networks are operating more efficiently, there's just a greater sense of control, that they feel that control is in themselves, a greater sense of happiness because of it. This was research done by Dr. Kimberly Schonert-Reichel at UBC, reduction in stress hormones, reductions in depression and anxiety are exciting to see. Next slide. And then these are just general comments that you can look at. What's exciting about Brad, at the Brigham and Women's Hospital, they're going to be doing 130 subjects with brain injury, doing the symbol relations program with them and tracking progress over a period of time. That'll be one of the largest ends that we'll have with Dr. Kim Wilmette, who's a neuropsychologist out of Harvard and then Brigham and Women's Hospital. So we're trying to get larger studies, more controls. This will just take time. I know with Dr. Lara Boyd, it was done, it seems like years ago, and it seemed to take forever to publish this research. And of course, I'm not in control of how quickly they publish or they put this data out, but there's still a ways to go, lots to learn. But it's exciting to be at the forefront of this and to understand this and try to get this information out to neuropsychologists and educators, Brad.
Fascinating work, Howard. I'm just so impressed at how much progress you've made since we first met in Calgary many years ago.
Yeah, it doesn't seem like enough, but it's getting there. Yeah,
well, welcome to my world. I got 50 publications and I retired. So, that's enough. It just takes a long time.
Yeah.
Matter of fact, my Trends in Neuroscience and Education article was the first article that I got published without revision. Mm-hmm. And I said, boy, it's time to retire.
Yeah.
So anyway, let's go ahead and go on to my next slide. I just see me.
I shall get it up there in a second.
Maybe I can do a little dance in the meantime.
Yeah.
Because physical activity will increase dopaminergic functioning in the brain and increase intention.
So I know that people are asking questions, so we'll answer those questions in the last 30 minutes. But post questions, please. If you have questions, post them. And the last 30 minutes, we'll.
Howard, I've got like an hour worth of stuff to cover. 7:49.
Maybe they'll stay longer with us. If we don't get to them, we'll answer them in written form and send them the answers.
Okay, so obviously I'm not going to go into a lot of detail in the slides that are remaining. Howard's presentation was excellent, but let's go to the next slide. What we're finding, and I just highlight these slides to show you that there are people doing neuroscience research on changes in brain functioning. And what we're finding a lot, especially in reading, is white matter connectivity, and we were talking about that in the chat room, is very important. When you look at Wilson's reading program, that's what they found. Next slide. And the way to think about white matter is like roads and highways in the brain. It's not about pieces, it's about roads and highways. It's about connectivity. And we've heard a lot about that from Howard, and I talked about that earlier as well. And what we find is that what's the white matter connectivity is what predicts reading changes with, better achievement in reading. Widespread changes in white matter diffusion rates and myelination and white matter maturation. This was interesting about these studies that I'm referring to here. It was a combination of white matter maturation, family risk for dyslexia, and psychometric measures, which were the best predictors of reading success. So that goes back to what I was talking about earlier with, it's not one thing we need to do as practitioners. We need to look at both possible biological issues, family issues, genetic loading, and so forth, and then also use our psychometric measures soundly and wisely to better understand how we can meet that individual child's needs, as Howard referred to earlier. Next slide.
And that's exactly what we're doing is we saw white matter changes so varied in our students, and we're trying to understand why. So you're exactly right. The white matter is one huge variable.
Yeah, and one of the things I mentioned last time is, look for the little things in kids. You can see stuff like if they're using white matter, or if they're using Broca's area to try to help them read. Broca's is a frontal lobe, left frontal lobe thing. They're actually connecting through white matter pathways to try to make the sound symbol association work in the back of the brain. And so watch for lip movement in kids, and watch that lip movement go away when they start to develop better phonics skills. And another thing that these studies are showing us over and over again is response to intervention is about using less brain, not more. And I think we've alluded to that a couple of times tonight, that more brain functioning is not always better. Kids with disabilities often use too much of their brain, and their networks are not well connected. So there's firing going on all over the place, and they're exhausted. And that's why teachers say, oh, give them less work. But guess what? They'll continue to be exhausted because they never get to the automatic pathways that are necessary for success. And to get to the automatic pathways for success, it's more about white matter connectivity than it is about anything else. At least that's what the research is showing us. Next slide. So we did a meta-analysis of reading instruction outcomes. And I'm not going to go into details with this, but what's really fascinating, you're going to have copies of these slides later on, so you can take a look at them, is this meta-analysis we did of reading instruction outcomes is that pre-intervention, the brains are different. Post-intervention, they look, the same areas are lighting up in both. So, I mean, the whole idea that Howard mentioned earlier, which is our false belief that learning disabilities need to be lifelong, is really not scientifically based. We can help kids overcome their learning differences by understanding them, instructing to meet their needs, and then encouraging success. Next slide. And this applies to number sense training as well. When you look at interventions, I mean, a lot of kids, I think I mentioned this last time, but they're given calculators in grade 3. They're given math facts tables so they can look up 9 times 6 is 54. But guess what? They don't have good number sense. So when we give them an independent, Howard and I talked about, life in the real world. You got to be able to use math in the real world a lot of times. And these kids who are given all these kind of crutches to overcome their weaknesses instead of remediating their weaknesses end up with very little understanding of what it means, what quantity means, and its relationship of it. So what you find is, like with reading, you find less effortful brain activity and more automatic brain activity when you remediate math weaknesses. Next slide. And so, here's another example of an intervention program which led to changes in functional connectivity in the frontal parietal lobe networks that Howard talked about. And in particular, the interparietal sulcus and its connectivity to the different areas of the brain. And it predicted math performance. In other words, how this connectivity changes is correlated with kids improving with math. So why not include an understanding of brain functioning in your assessments and in your data collection and doing an intervention to see if that connectivity is improving? Next slide. And so we did a meta-analysis on math instruction outcomes. And lo and behold, it looks, I mean, there's different networks, of course, but it looks a little similar to what we see in reading, in which the post-intervention, the dyscalculics look pretty similar to the typical kids. And not entirely consistent. There are some differences still. But the reality is what we want to do is we want to improve brain functioning We want to address deficits. We want to remediate the deficits. And that's one of the things that Howard's program is doing, is making sure that we address the weaker areas, not ignoring them. And that's what we often do with accommodations in special education. We say, ignore your disability, like you got a hole in your brain, and just get around it because you're disabled, instead of saying, let's build the areas you're not weak in. Let's make sure that when you get out there and you have a tennis ball and a tennis racket in your hand, that you have the ability to practice that sport until you get good at it, like my buddy, Dr. Kim Fitzer. Next slide. And then next point. You know, when we presented this, one of the things we concluded is neuroplasticity is evident following math training, with math competency showing less effortful processing and increased access of routinized skills through the memory networks. So our goal is to help our children succeed by making learning less effortful, by increasing efficiency of the brain networks that we're talking about. Next slide. And I want to talk a little bit about ADHD, because it's another thing that we really don't pay attention to. Most people only pay attention to behavior in ADHD. And my own research in different universities has shown a couple of different things. One of the things that we often do with ADHD is we say, we still, unfortunately, even though it's a brain-based neurodevelopmental disorder, we still only pay attention to behavior, because it's the disruptive behavior we don't like. And what we found in our research using medication, and you know, medication isn't necessary for all kids with attention problems, but kids with true ADHD, I think it is. And true ADHD, we were able to establish with our neuropsychological testing. And it's a battery, it's only about an hour long. Email me back channel, and I'll be glad to share the battery with you. But it really picked up not only whether a kid had ADHD or not, but whether they responded to medication. And so we did double-blind placebo-controlled trials of ADHD. And if you look at the first part of this slide, what we found is kids that didn't have impairment on our executive function battery didn't respond to medication, or they responded minimally. What we found, though, which was even almost more interesting, is the kids that did respond to medication significantly, which are the two bottom curves down there, moderate and significant executive impairment, not only showed a strong response to stimulant medication, but they showed a different response for cognition than working memory. And what we found, and that's the middle slide there. Notice lower is better on this graph. So notice the best dose for this kid in the middle graph was the low dose for their cognition, but the high dose for their behavior. You wonder why kids don't get better academically or on stimulant medication? It's because we give them too much medicine for their cognition. And my graduate student, Dr. Hannah Cubis, now a professor, I believe, she showed it was working memory. Well, working memory is pretty damn important for learning. And when on high doses of stimulant medication, the working memory declines. It gets worse. And I think we found an example in our spectroscopy analysis, which is the last slide, which is that glutamate, which is important for memory, is improved on low dose stimulants, or when we titrate the medication based on cognition, versus when we titrate it based on behavior, which glutamate goes down. So this was an exciting finding for us, because glutamate's so important for learning. But you know, one of the things you'll see in the behavioral research of ADHD is glutamate always gets worse on medication. But that's because physicians and parents and teachers are all picking the dose that's based on behavior, not based on cognition. So what we've argued in our papers is, next slide. Next point. Even for strong methylphenidate responders, the best dose for neuropsychological functioning was typically lower than the best dose for behavior. So what we argue is, why not titrate the medication or choose the best dose for medication to optimize cognition so they can interact better with their environment, they can learn better from the behavioral techniques used in the classroom. This hasn't changed pediatricians' practices. They're still told pretty much to titrate or choose the medication based on behavior alone. And unfortunately, that's why kids with ADHD continue to struggle. It's because we're making their cognition less effective and less functional. We're actually decreasing that network as opposed to the behavioral network. Next slide. And, you know, just to highlight, again, some other people who are doing research on that, which shows that the frontal parietal network that Howard was talking about is pretty damn critical in learning, and that it predicted performance on working memory, mental flexibility, and executive control tasks. And so we need to kind of think more carefully about cognition in our assessments and how that impacts our the effectiveness of our treatment and our choice of treatment. Next slide. And I just want to highlight this for you. This is for the people out here who read the school psychology literature who say there's no relationship between cognition and learning or learning outcomes, because you hear that a lot in the school psychology literature. But here's a special issue Doug Fuchs and I did. Doug Fuchs is a fairly prominent researcher who's an educator and a psychologist and an amazing guy. And anyway, every study we picked for this special issue made sure that we addressed the relevance of cognition for intervention. So check this out. It's a bit old now, but I think many of the points made. Matter of fact, one of the studies by Jan Fritters really showed that beyond the behavioral approach or the strict academic approach, cognition plays a role in intervention. Next slide. So I know we're going super fast, and I'm super sorry for that, but it's 8:04, and I do want to have time for people's questions and answers. So I'm just gonna fly through these slides. You'll have them available to you, but next slide. So what we did in our paper that we did for the Singapore government is we contrasted what is done in standard approaches to curriculum instruction and behavior, and then what a brain literate approach could do. So I'm not going to go over these. You're going to have them in your handouts, but we really don't have enough time to get into them given our time limitations. But what you can see is the standard education approach in the first column, what the expected outcome is for that, the brain literate approach to education, and the expected outcome with that. And I think if you read these slides carefully, you'll see that some of the choices we're making in our standard education or practice special education approach really undermine children's brain development, which is something I highlighted in the last presentation we did last Tuesday. Next slide. Next slide. And so then we go into instruction. So curriculum is what we deal with next. One of the things we did with my brain game team was with curriculum is we actually went to the, we were hired by the Ministry of Education in Edmonton, in Alberta, to consult with them on their curriculum development. And what we found was, because they didn't know anything about the brain, they were writing goals and objectives that were contaminated, like talking about letters in the same place that you talk about words in terms of reading recognition. And they're different. I mean, they're related, of course, but you can recognize words without recognizing letters. You can recognize letters without recognizing words, as I talked about last time. Next slide. And so again, we've got, kind of things, word reading problem interference with comprehension. That's the third point here. Students who have difficulty with reading are read to and then answer questions. Well, guess what? That's not reading. That's called listening comprehension. Students unable to access knowledge and content unless someone reads it to them. In a brain literate cause, you determine the cause of the reading problem and build literacy to allow access to the written materials in multiple settings and multiple modalities. And so children read and comprehend adequately and use reading skills in other classes or independently. Next slide. And the last one here in instruction, I really like to highlight because almost every kid in special education I've ever met on their IEP, one of the accommodations is fewer problems, less work, no homework, alternative assignments. And those all sound nice for a person who's not brain literate, but here's what happens. So work completion. Students are given less homework. This is the last point on this slide. Students given less homework or fewer items to complete during in-class assignments, especially if it has difficulty understanding content. And then the expected outcome. Student works to achieve minimal amounts of work, has difficulty with mastery and fluency of anything, making higher level learning and independent learning difficult. And Howard pointed that out earlier. A brain literate approach, student needs more items and practice to automatize skills. Subsequent learning is more difficult and mentally taxing if basic skills are not automatic, even if accurate. So, just giving less problems or less assignments or no homework because they're tired, they're too mentally taxed, is the exact opposite because they'll continue to be mentally taxed. They will never feel successful and they will feel constant failure unless they're propped up by giving, fewer items, getting a couple right or whatever. And so the expected outcome for a brain literate approach would be the student not only is accurate, but fluent in performance, freeing their working memory for better understanding and making new learning less arduous and time consuming. So it's just, what neuroscience has taught us. And it goes back to what Howard was talking about. The brain connectivity can't happen if we're doing less in practicing a skill. We can't automatize things in the cerebellum or the temporal lobe if we never practice it enough to get there. So you've got to help students, and Howard brought up that point last time, you've got to help students to realize that you've got to do a little bit more to get good at this because it's an area that's a struggle for you. But the payoff is learning will be easier for you and you'll feel successful and you'll feel more like your fellow peers instead of feeling disabled. Next slide. And so keep going, brain literacy, there's technology. Oh, the last one, technology and math. Like we give them calculators, we give them these multiplication tables because they don't need to know that stuff. Well, guess what? Higher level math is really poor when you do that. Okay, you don't ignore the basic skills of quantity and number and math facts. And, it's kind of like, again, we need to teach them multiple ways of solving problems. But then they have no number sense and they have no idea whether they solve the problem right or not because they have no basic conceptualization of quantity and quantity, number, and symbol relationships. And if you don't have that, good luck solving algebra or calculus or statistics. It's too hard to do if math is just a rote kind of thing for you. So next slide. And so go ahead. I'm just going to skip over these. You can read these yourself. We've got brain literate approaches to behavior. And, just out of the virtue of time, I just don't have time to get into this. And so we've got several, let's go back to the last one, just for one, multicultural and gender differences in problem solving. In a typical approach, teacher prefers single approach to problem solving and recognizing culture and doesn't recognize cultural or gender differences. So cultural or gender differences not recognized, group success or failure, regardless of the approach, solution, or timely completion. So again, if you don't get it my way, then it's going to be a struggle. So then what a brain literate teacher will do is looking at collective versus individualistic styles in learning, relating that to hemispheric preferences and brain functioning, and brings that and integrates that, making better or quick solutions, females more sophisticated approach, but more time consuming, for instance. So recognizing differences in all these diverse areas is important. So what happens there is the problem solving style is understood and appreciated, recognize that difference is expected, and different problems better solved using different approaches. That's kind of what they're trying to do in math now, but they've ignored all the precursors to developing those different problem solving styles. Next slide. And next point. So one of the things that we argue in this remediation versus compensation paper is children should be provided with systematic brain-based differentiated instruction in inclusive classrooms to prevent skill deficits. Compensatory accommodations can be good to access the curriculum, but they're not a substitute for developing the skills. So like one of the accommodations that some of you might have heard of before is the teacher outlines the key concepts in the passage for the student. And then the student says, these are the key points in the passage. Well, who did it? The teacher did it, not the student. So what you have to do is you have to teach the student what are the key concepts, why are they the key concepts, how are they organized within the paragraph, and stuff like that. Accommodations may get us through the day, but they don't help the student feel better about their education or more successful in their educational experiences. We need to provide them with the skills so they can overcome their challenges. Next slide. So here's a case study from assessment to intervention that I'm going to highlight, and holy cow, 8:14. All right, quickly. Here's just a kid that we looked at, and I talked about this last time, the different brain areas involved in reading and why they're involved, including the striate cortex and the occipital lobe, the fusiform gyrus, superior temporal gyrus, angular gyrus, Broca's area, oculomotor. All these could be different causes of reading disability. When you read an article or you hear somebody say it's all phonological awareness and it's bottom up from there, and so it all, no, these are different brain areas. I can guarantee you, I can show you, I'll bet you $1 million, anybody out there who says you can find a kid who has good phonological awareness but poor working memory. Okay, I'll take that bet on. $1 million, want to be rich? Go ahead. Anyway, next slide. Now, remember we talked about last time the differences between the dorsal and ventral streams. So that's important in this particular case study. Remember, the dorsal stream is for decoding. So a nonsense word like "ugh" is a good example of something you have to decode. But it also applies to words that you have to decode because you haven't learned them enough. And we went through specific examples last time. If you have to recognize a word by sight, which is most of our reading, it's the ventral stream, the bottom stream there, that reads the word by sight. And remember what I said last time, we read by sight, we read by sight, we read by sight. But if we don't know a word, we got to try to decode it on the dorsal stream and sound it out. And so that's why we want to look for that lip movement during reading, because that means they're using that Broca's area to try to decode that word. Now, you still use the dorsal stream in typical readers without seeing the lip movement, but typically in kids with traditional dyslexia, you're going to see that lip movement often. So next point. So a great example of why we need both streams. If I said, raise your hands out there, that everybody knows what a stethoscope is, right? But how often do you see the word stethoscope in your actual daily life? You knew what a stethoscope was when you were 3, when the doctor pulled it around his neck, put it in his ears or her ears, and started listening to your heart and your chest, right? So everybody knows what a stethoscope is. But if you can't decode in that dorsal stream because you don't recognize stethoscope by sight, you're out of luck with comprehension, aren't you? Because if you read the sentence, the doctor listened to my heart with a stegosaurus, it don't make any sense, right? So you need both streams. It's not a contest of whether decoding, whether phonics is better or sight word approach is better. You need both to read successfully. And I highlighted that in our case study last time. So next slide. So this is a study that we did at the University of Calgary when we were there, and Dr. Fitzer presented on this. We basically did interventions following comprehensive evaluation. All these kids were in a special ed school. So these were kids who were non-responders in a school designed for kids with learning disabilities. And what we found, next slide, in this one kid we evaluated, we used this evaluation approach, which I really don't have time to go into given the lack of time, but it's about trying to link assessment to intervention. It's what we call the cognitive hypothesis testing model. And we carried this out. We figured out what the kid's problem was. Next slide. And we said, oh, this kid uses a phonological approach to word reading, reducing reading fluency and comprehension. Why? Because they had limited visual object memory for words, and they had poor cross-modal matching, so they couldn't link words to sounds very well, and limited practice because she complained she never wanted to go to school. She was always sick. She hated school. And so it really suggested to us that she could decode just fine, like a hyperlexic, but could not read by sight. So that ruined her speed and that ruined her comprehension. So we developed an intervention based on that. We said, geez, we've got to build sight word recognition. Not phonics, she's got phonics. We've got to build sight word recognition. So we used an empirically based approach that's well known in the field called infolding, which is you flash the card up to the kid for just a second and then you put it down. And if they can get it, you put it in the learn pile. And if they can't get it, it goes in the unlearn pile. Well, then at the end of the session, you take the unlearn pile and you take them through the word and the meaning and everything else. And then you try it again next time. So, you know, it's not like we're saying, you know, stick your finger in your ear and, you know, up your nose and twirl around and flashing lights. We're saying, let's use an empirically based approach based on what we know you need. And let's collect data on it. So we did. And you can see, next slide. What we showed was that what we did was we took key words from each of her classes given to us by the teachers. And that's what we used for our sight word learning. Okay. So it wasn't removed from the class. It was actually using sight words from the class. And again, if she got them automatically in the learn pile, if she got them not automatically, they went in the unlearn pile, and then we taught the unlearn pile. And periodically we would take from the learn pile and throw those in the next week just to make sure that she's retaining those, right? And what we found is her sight word recognition went up quite a bit, as you can see. But what we also found, next slide, is not only did her achievement go up quite a bit, but also we saw changes, like Howard said earlier, in the brain network connectivity. And it wasn't only about increasing functional networks, it was about decreasing or increasing dysfunctional networks. It was also about decreasing ones that were compensatory. And all of a sudden, the little girl who hated learning, hated school, hated reading, was sick every day, liked coming to school. And maybe that's the most important outcome. You know, the hell with the brain changes. The fact is, she loved going to school after we did our intervention. And, you know, we didn't solve all the problems because she was still a slow reader. She still liked to try to decode things. So we did repeated readings, which is another evidence-based practice for increasing reading fluency to try to improve that as well. So, you know, this process is one of the scientific method, which is you take a hypothesis, you try it out, you collect data, and then you see if it works. And then you change the hypothesis or the theory, you change the hypothesis, you change the outcome, and then you have until you experience success. So if we did this with every kid, guess what? We could, I don't say we can get rid of all disability, but we can certainly make it less dysfunctional. And we need to tell kids that disability is not something that's lifelong. Appreciate your strengths and weaknesses, build on your weaknesses, grow as an individual. And once we get them to feel like they're growing and improving, like this little girl all of a sudden loves school after she hated it for years. Oh my God. You know, I mean, that's a powerful enough outcome. The hell with the brain stuff. You know, I mean, the fact is, if you're understanding how a kid learns and you can help them overcome their challenges and they feel successful, you're going to go a long way in making big differences in kids' lives. Next slide. So, got to sell my book, the last slide. Next slide. My books. So give me a, you know, be free, check out my website at www.teachingbrainliteracy.com. And my emails connect at teachingbrainliteracy.com if you want to learn more about this stuff. I do more extended trainings. Instead of trying to cover this stuff in 4 hours and 2 days, I cover it over 3 solid days of training. You really want to know how to improve your outcomes. It's not going to happen in a 2-hour training. But at least I've hopefully planted some seeds, and Howard's planted some seeds for you tonight that will make you think differently about what you're doing. So let's go ahead for Q&A, hey?
Yeah, thank you, Brad. That was awesome. I love the holy cow terms and up your nose terms. You always entertain me. So you keep me a bit nervous, but engaged with what you're saying. Yeah, let's go to questions. Sandra, do you want to come on too with us, Sandra? And you might have been following the questions a bit more than me here.
Yeah, I don't know what's in our chat room down there.
There we go. Yeah, sure. I think, Brad, you answered the first one there. Where was that one there? I'm just looking. But just in case you want to elaborate on it, what are some interventions that improve processing speed as measured on the WISC-5? And you had written there, but if you want to elaborate.
The Arrowsmith program.
Yeah, I had talked about repeated practice and, you know, using some of the techniques that Howard talked about. Repeated readings is a common one in the empirical literature for reading. And just cross-modal integration, doing tasks that require you to integrate different, you know, senses and connectivity with the frontal lobes in terms of control of that, being to alternate between different modalities and things like that. So, you know, if it's a true process, and I think I said something like, there's lots of causes for low scores and processing speed that aren't just, you know, speed of performance. But if you're thinking straight processing speed, you're thinking white matter connectivity. And so to do that, you know, like, you know, that repeated codings practices. Coding is highly related to reading, believe it or not, even though it's a visual number symbol task. So, you know, repeating coding over and over again. But Howard has some great tasks for that. And I'm sure clocks helps with that as well.
Yeah, I mean, you should, when you sit behind a student who's mastering, say 6-handed clocks, the rate of speed that they're analyzing the concepts, the symbols, the spatial information, the concepts, you just are blown away by how fast their large scale brain networks, white matter connectivity must be at that point. But when you saw them initially, they couldn't read an hour clock. They didn't know what the hour hand meant. If it was between 1 and 2, they didn't know if it was 1 o'clock or 2 o'clock. So it takes time. I think this is the other thing, Brad, this stuff takes time. Like, we're in a fast food, culture where you want your McDonald's right away.
The quick fix.
Yeah, this stuff takes time. Like, there's CogMed and Fast Forward and 5-week programs, but what I see is a year, 2 years, 3 years to build these white matter connectivity. It depends on the severity of the issue, but it takes months and months. And but if you do it, you stave off a lifelong of suffering, is what I think. And it's not a quick fix.
I mean, just a simple a task from the mini mental status exam that neurologists give is flipping the hands up and down on the legs. Okay. And how quickly can you do 50 of those? Well, can you do it, if it's 60 seconds today, can you do it in 45 tomorrow? Mm-hmm. So, and I know that seems unrelated, and certainly we can talk about more specific academics to build processing speed, but it's got to be about how do you build that connectivity of frontal and then left and right connections. Because all the research, the research both Howard and I shared tonight shows that changes with intervention happen through increased white matter connectivity and decreases in other dysfunctional pathways.
Yeah, and the more novel learning you do, the more education you get, the more white matter connectivity you have, the more buffers you have for aging, cognitive decline. And we've seen that with TBI, traumatic brain injury research, that those who suffered a TBI that was, say, a graduate student who suffered a TBI, their recovery, bending other variables, seems to be faster than someone who maybe never finished high school and not engaged in novel learning. So certainly it's a huge benefit to the human brain to constantly challenge yourself with novel information.
Next question, we were asked if the Arrowsmith program is available online, and yes, it absolutely is now. And so I just did put my email address there in the chat, admissions@eatonarrowsmith.com, or you can check out our website at eatonarrowsmith.com for more information. I'm always happy to talk through options with you. So that is that one. And then Macy writes,
I'm available online too.
Yeah.
Fantastic. And we'll send out all that information as well. Macy writes, super interesting to see the studies that have been done on the Arrowsmith program. She has 2 questions. Number 1, have you heard of Annie Hopper's work and dynamic neural retraining systems? And if so, might there be any overlap with learning disabilities or the Arrowsmith program?
I haven't. Brad, have you?
I have heard of it, but I don't know enough about to comment on it. But I think that the approach is very similar. That it's about creating those pathways and doing repeated practice.
You know what's interesting? Just an offshoot. There are schools for children with learning disabilities that focus on curriculum, small classes, getting kids through high school, and then you have programs that could build cognitive capacity and limit lifelong dysfunction, cognitive dysfunction. And I think culturally, parents and educators are still leaning towards got to get kids through curriculum, right? The cognitive capacity changing is still not really triggered and not understood. And I think this is part of this brain literacy concept that we're talking about, that we're still, like if you go to a conference on learning disability and you go to, most everything is on compensations and strategies, workshops, they're not on building capacity. And so it's still so frustrating to be at that level of lack of awareness.
Yeah, and that speaks to Macy's second question. How could a teacher or school go about adding or incorporating these types of interventions when the current school culture is that of a typical RTI 504 EIP approaches?
Well, that's a really hard question. I think that's maybe where, I mean, one of the things that we tend to focus on, like Howard said, is getting through curriculum. And curriculum tends to be very left hemisphere focused. So my approach to that, I mean, Howard's and Arrowsmith's approach is a little bit different than mine, because my approach is we need teachers to better understand how the brain intersects with that curriculum. I shouldn't say we're different in that way. I think both of us agree about that. But I do feel, as an educational neuroscientist, one of the frequent complaints I get is we don't have enough time in the day to do extra activities. So my approach with brain literacy is you need to be able to adjust your instruction to the curriculum you need to cover in the amount of time you have from a brain literate way, so you're addressing those individual differences. And it's probably not as powerful, to be honest with you, than doing the direct training that Arrowsmith and Howard does. The problem is not a lot of people want to commit to extra time throughout the day. So there's a tension there. So maybe you could address that, Howard.
Well, I know that there are schools now in Australia, Montreal, Spain, that are putting, a program like Symbol Relations in a curriculum for all of grade 3, because they know the benefit is for all children, and it would limit learning difficulties, in grade 4 or grade 5. So there are schools that are doing this, and they're pioneers. They usually have leadership that is very pioneering, interested in changing the way they do things. I know that the Toronto Catholic School Board did a study on Arrowsmith, and they had the program in their schools for, 14 years. And the kids who did half a day of Arrowsmith there was only sort of like 5% who needed special ed resources afterwards. And imagine the cost savings to the school district, right? But they still eliminated it because they were on a budget crunch and they couldn't afford extra programs, and parents sued and got another year out of it. But even though the data said to the schools, if the kids who are struggling did half a day for 2 years, 95% don't need special resources, they still cut it, right? They had the data, right? The data spoke. And I think, this is the frustration that we see, but there are schools that are interested, that are doing things that are different. But again, it's a very tough road. I won't see it in my lifetime, but we're doing whatever we can to get as much out there.
Certainly, and Jason, we agree with you. We believe that as well, that we need to challenge the current culture, and that's why presentations such as this are so important.
Teaching is changing brain function.
Yeah.
And if we just accept that as our basic premise, how we go about changing kids' brain functioning is, there's different ways to do that. And so that's the most important thing. Most people, like I think Howard said earlier, or maybe you said, Sandra, everybody thinks the brain's static, like it's just a vesicle that just sits there.
And teachers are hungry for this.
Yes, they are.
They just want this information. And I taught at the University of BC. I taught courses on learning disabilities, and I brought in brain education, and I was told to spend less time on that and more on curriculum by the senior professors. So it's so hard to do that, but more education departments are looking at neuroscience. Those things are happening. Harvard, Vanderbilt, UBC has a neuroeducation idea. Stanford. Yeah. So, but if you look at teacher curriculum training per certification, I haven't found one that has a course on brain and impact on education.
That's sad. That's what our job
It
is
really
to
is.
change brains.
Yeah, yeah. I mean, I have, imagine a school, you walk in, every public school is ready for this. Like they're ready to look at neurological functioning. They're ready to look at individual differences. The teachers are trained on neurological functioning. They understand curriculum needs, and they have time to balance it. I know what it would look like. It's just, a roadblock to get there.
Yeah, when I was at University of Calgary and I, gave a giant lecture hall to 400 or 500 kids, how many ever it was, young adults, I should say. Kids compared to the old man like me. They would come up after the lecture. I'd be there an extra half an hour after every lecture. Mm-hmm. Because they'd be like, oh my God, why haven't we learned this? Mm-hmm. We're doing, yarn exercises to look at systems, and we're doing, fallback things.
And it's made, as a professional, it's just made me more aware of individual differences and kind and considerate. Like when I'm in a store and some person is trying to communicate an idea to a clerk, and I can see how difficult, and I could see the clerk roll their eyes. I mean, I understand, the problem the customer has in trying to communicate is a cognitive functioning thing. It's not that they're a weirdo or mm-hmm. being a pain in the butt, right? They just have this neurological deficit.
And we fall back on, why aren't you normal?
Yeah. And the more we teach our students this, they gain that same compassion for others when they can have a true picture of why someone might be struggling in a certain way. So it has such ramifications. And just to build on Elaine's point, she's agreeing, very informative and interesting. She's a retired educator. She'll be letting her relatives currently teaching to know about this important work. Thank you, Elaine. I'm going to move on to Rachel's question, because we're often asked this. If you build the white matter connectivity, can it later return to the lower baseline level post-intervention?
Well, I think it changes constantly in your lifetime, depending on what you're doing. But when we looked at brain injury, that if you have education, if you're doing novel things, that white matter seems pretty robust, and even after a brain injury, it's pretty stable. So we don't see a loss of function in our students over 10, 20, 30 years. So we don't see, once you engage it in the functional way, it begins to operate effectively, unless there's some trauma or some emotion disturbance or environmental impact or organic impact. That's what I've seen, Brad.
Yeah, well, neuroplasticity is a bidirectional thing, as I talked about last time, that it's not always improvement. Mm-hmm. You can also take functional pathways and destroy them.
Like OCD, for example.
Yeah, or PTSD, post-traumatic stress disorder. But the likelihood is, if you carve out functional paths, they will be reinforced because the student is experiencing success. So the likelihood of them throwing those all away, unless they're in some weirdo codependent relationship where they're making them, bad stuff going on, it's likely that, those pathways will continue to strengthen over time, because, like the little girl I talked about where we did our intervention tonight, she felt great about school all of a sudden. She wanted to go to school. She's like, oh, I can learn. I can not only learn in my reading class, but I can learn in my science class. And I'm successful and I feel good about myself. So, likelihood is that pathway is going to continue to strengthen and grow. And that's part of how the brain chisels itself to function in the real world. And if the real world is understanding and accepting and accommodating and supportive of developing those positive pathways, we're gonna have a good functional brain, that is good for the environment. Anyway, other questions?
Just a comment from Amy. I hope I'm pronouncing your name correctly. Analog clocks and counting change are big challenges for the kids I assess. Again, symbol relations.
Yeah, I mean, I wish I could contact the thousands of parents, kids I tested, where I said, don't worry about reading an analog clock. Like prior to me knowing, in our careers, we often go, oh my God, what did I do back in the old days? But it's a huge sign of significant problems down the road if they're struggling with analog clocks.
And what was so exciting to hear from you guys tonight as you're talking is how that translates or generalizes to other skills.
Yeah.
And if you think about it from a neural network perspective, of course it does. It's not just about reading spatial relationships.
Right.
It's about connecting relationships.
Yeah. Yeah.
And so that's important. And matter of fact, I was going to ask you this question, Howard, and you answered it before I could ask it. But I said to myself, well, I'll bet you that translates into better math problem solving and better comprehension. And you said, yeah, it does.
Yeah,
I was like, you got it out before I could ask the question.
Yeah, no, it blew my mind. When I started seeing this, hearing about it 20 years ago, but actually practicing it and watching it and seeing it in the data and seeing it in the MRI, seeing it in the brain, it just makes me more motivated to get this out there and get it available to all kids, not just kids, as you're saying, with learning challenges, but it's kids who might need a boost or who, could do more in terms of understanding, math than they are. So anyways, I know we don't have a lot of time here.
We're way out of time.
Way out of time.
I cut Sandra off though. Sandra,
No,
I'm sorry.
that's totally fine. I was just going to read Gerard's comment because he nicely wraps everything up for us. He said, thanks so much. There the question is, or the comment, but we need a whole series of these webinars, and we certainly agree. And I know Brad and Howard, you've talked about that. And so I think everybody needs to just stay tuned because that's coming, isn't it?
Yeah, Brad and I will be talking over the holidays, and why don't we create a 6-class webinar or something like that and get into this stuff in more detail.
Right.
Yeah. Was that a great, oh my God, I don't want to do this, or great, I want to do this?
No, it'd be great to cover very specific areas.
Yeah. Like dyslexia, dyscalculia, attention disorders, executive functioning. Maybe we make
autism.
Autism, yeah.
Yeah.
All right. Sounds
Fantastic.
Great. Thank you, everybody. Have
Absolutely.
a great
We'll
evening.
be sending everything out tomorrow. We'll be sending out the recordings, so don't worry if you missed anything tonight. And thank you, Brad. I'll let you have the last word there.
Do we have Howard's? They have on the PowerPoint my email address, but do they have Howard's as well?
I'll get everything to them. No problems.
No, they're just going to email you all the questions.
Strategy.
You can do it, buddy.
Happy holidays, everybody.
All right. Take care, everyone. Thanks so much for joining us. Bye.
All right. Take care. Bye.